Alright, in this video we're going to talk about fitting a linear model to data. So with this we're going to get into residuals and residual plots. So we're going to be going more into scatter plots and then building upon it. So a residual is the positive or negative vertical distance between a data point and the line of fit. A residual plot is a visual that keeps the data's x value but changes the y variable to be the residuals. When you make a residual plot, you want to see it be scattered. You don't want to see an obvious pattern. And then the least squares regression line is the line of fit for which the sum of the squared residuals is as small as possible. Alright, so this distribution of the residuals about the x-axis is random and tight. So the line of fit is very good for this data set. The second one, the distribution of residuals about the x-axis is random, but it's a little bit loose. The line of fit for this data is good, but the model's a little bit weak. And then the distribution of residuals about the x-axis is not random for the third one. The line does not fit the data very well. So you can see that there's a pattern. It's decreasing and then it's increasing. Alright, so the table below lists the ages and heights of 10 children. So I'm going to make a scatter plot of this data. So 230, 333, 334, 437, 435, 438, 540, 542, 543, and 642. And then I'm going to do my best to draw a line of best fit. Alright, so question 2, a student's fit the line H equals 3.5a plus 23 to the data set. Graph the student's line above, then calculate the student's predicted value and residual. So I want to calculate their predicted values using that equation, 3.5a plus 23. So I'm going to take that equation and I'm going to plug 2 in for a, then I'm going to plug 3, I'm going to plug in the different ages to get the predicted values using that equation. So when I plug in 2, 3.5 times 2 plus 23 gives me 30. Now to get the residual, I take the actual height, which was 30, and I subtract the predicted height, which was also 30, so I get a residual of 0. Now I'm going to plug 3 in for age. 3.5 times 3 plus 23 gives me 33.5. So when I do my actual height, 33, minus my predicted height, 33.5, I get a residual of negative 0.5. Again, my age is 3, so my predicted value is 33.5. 34 minus 33.5 gives me a residual of 0.5. Alright, now my age is 4, so I'm going to plug 4 into the equation. 3.5 times 4 plus 23 gives me 37. 37 minus 37 is 0. Again, my predicted value is going to be 37 with an age of 4. 35 minus 37 gives me a residual of negative 2. And again, 38 minus 37 gives me a residual of 1. Now the next three ages are 5, so 3.5 times 5 plus 23 gives me 40.5 for the predicted value. 40 minus 40.5 is negative 0.5. 40.5 again. 42 minus 40.5 is 1.5. 40.5 again. 43 minus 40.5 is 2.5. And my last data value, the age is 6, so I'm going to do 3.5 times 6 plus 23, which is 44. 42 minus 44 is negative 2. Now I want to use this graph to make a residual plot. Well, when the age was 2, my residuals were 0. When the age was 3, my residual was negative 0.5 and positive 0.5. When the age was 4, one of my residuals was 0. Another one was negative 2. And another one was positive 1. When the age was 5, I had a residual of negative 0.5, positive 1.5, positive 2.5, and when the age was 6, my residual was negative 2. So you can see at this residual it's kind of fanning out. Alright, so it looks like there might be a pattern. Based on the residual plot, how well does the student's line fit the data? The line fits it okay, but because the residuals seem to be increasing as the age increases, that gives us signs that there's some sort of a pattern, so it might be a little bit of a problem. Use the student's line to predict the height of a 20-year-old man. Discuss the reasonableness of the results. So I'm going to use their equation, h equals 3.5a plus 23, And I'm going to plug 20 in for my age. 3.5 times 20 plus 23 gives me 93 inches, which is 7 foot 9 inches. Now, this is not reasonable. This is called extrapolation. And we cannot extrapolate that far when our data ranges from 2 years old to 6 years old. So 20 years old is way further out than any of the data that we have. So that would not be a good prediction.